So let's have a look at some principles of this thing called defensive design. And this is the idea that people who use your programs might fall into one or two camps, and that are people who are deliberately trying to damage or hack into your program, and they could fall into the camp of people using your program in ways you're not really thought of or not expected. And we're going to cover how to try and protect against a few of these things. And the first thing we're going to have a look at is this idea of authentication, and this is quite simply making sure that you've got usernames and passwords set up for people, so they can't log into the website or can't use your program rather if they are not allowed to. So let's give you an example of that. Very simply, we're going to be using the worst website a lot today. We've got a username here, let's say it's in Hulton, and then my password is 1234, which is a terrible password, but it's the one I've chosen, and I can log in with that. That's fine. But if I type in my username and a different password and hit login, it doesn't let me. It says unauthorized to be your hack proof, which is a bold claim indeed. But let's have a look what happens if I do this. I'm going to type in my username and I'm going to put a special character in. You see that there, that apostrophe? That is really important. And then I'm going to put this curious command in afterwards, this 1 = 1, and hit login. It's let me in, even though that's not my password. And the reason why is because I've used this thing called an SQL injection attack, and I haven't sanitized my input. So there's a principle for defensive design called input sanitization, which is where we remove every single special character in there which should not be there. And what I mean by special characters are things like apostrophes or a double equal sign or double negatives. They've got no reason to be in a username or a password a lot of the time. Right, let's see what happens if I try to create an account. My program here has to have usernames in letters only, which is fine. That's a lot of websites can have that. But what happens if I've typed in a username and tried to create an account which has got letters and numbers in? Oh dear, I've broken the website, and that's because I haven't validated my input. So I've got this idea of input sanitization, but I also need to make sure I validate all my input as well. And this is just purely checking that data is in the correct format, the format that you expect it to be in. You know, if you ask somebody for their age, you probably assume that a lot of people type in the number, but you can be sure somebody's going to type in their age as a word, and that can crash your program. If I turn on validation, so I'm going to put on here where I validate my username, and I try to create a new account with numbers in it, then it shouldn't let me anymore. There you go, validation, username must include letters only. That's validation. That's an important part of defensive design. Another part is this idea of verification. If I try to create a new account, let's just call it NHU like that, and then I type in the password, but perhaps I fudge it a little bit. I type something wrong when I'm doing it, and my password's not what I expect it to be, and I hit create login. It doesn't let me create my user account because my passwords don't match. So that's verification there. It's checking to see that users have entered what they thought they had. The last piece of defensive design, which we're not going to cover in this video, but you need to be aware of, is this idea of making maintainable code. So creating maintainable code. So that's all about comments, about using indentation, about using sensible variable names, all that, and we'll cover that in another video. And they're your principles of defensive design. If you found that video useful, please hit the like button and hit subscribe to the channel. Keep learning and revising more computer science by clicking on the videos linked here.